Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today, we will go through the core concepts related to the introduction to GNSS, working principle, its types, and trilateration concept. What is meant by GNSS? It is a global navigation satellite system, which is the standard generic term for satellite navigation systems that provide autonomous geospatial positioning with global coverage. Here, the GNSS, which is the umbrella, under that the GPS, GLONASS, Galileo, and BeiDou are the systems which are work collaboratively or independently. So GNSS stands which provides accurate geospatial positioning and navigation services in the worldwide. GPS specifically refers to the United States, while GNSS represents all global navigation systems together. Remote sensing and GIS applications depends heavily on the GNSS for more precise location referencing and spatial data collection point of view. So in civil engineering domain, we are using the GNSS which supports surveying, mapping, construction activity, layout, transportation planning, and infrastructural monitoring, and many more applications. The evolution of satellite navigation, which is of the three phases. First phase, which is the Doppler shift. Second one, the time of arrival. Third phase, multi-constellation. First phase, Doppler shift, which depends on the transit system. The first phase of satellite navigation use Doppler shift techniques in the transit system for approximate positioning. Second phase introduces GPS technology which calculated location using signal propagation, time between satellites and receiver, that is time of arrival, where revolutionized positioning is carried out. And in the third phase, simultaneous operations or multi-constellation operation of GPS, GLONASS, Galileo and BeiDou improves availability and positioning precision and accuracy. So with reference to the civil engineering, this modern GNSS which supports real-time in navigation, accurate topography surveys and intelligent transportation system based on these three phases. They are related to the positioning for navigation or for time or real-time data collection. That is system architecture, where the three segments are step by step, complete comparatively or continuously working together to collect the data or to process the data, where first segment will be the space segment, second one control segment, third one user segment. So GNSS architecture is divided into three major components or segments: space, control and user. The space segment consists of orbiting satellites that continuously transmit time coded radio signals or real time radio signals. Control segment includes monitoring stations that track satellite orbits, correct errors, and synchronize the atomic clocks, where the user segment contains GNSS receivers such as survey instruments, smartphones, and rover systems, which receives the signals to calculate position passively. In civil engineering point of view, GIS applications based on these three segments work together for maintaining the accuracy, precise positioning, and mapping operations. The basic principle or working principle for satellite ranging, where the GNSS calculates distance using the principle, that is distance is equal to velocity into time, where the velocity is measured in the speed of light and time is elapsed time, that is the transmission to reception. Here the satellite signals travel at the speed of light from the satellite to the receiver. The receiver measures the travel time of the signal to determine its distance from the satellite, where a microsecond timing error can create position error of approximately 30 meters in the ranging. In remote sensing and GIS, accurate timing is essential or more important for precise georeferencing and engineering surveys, which is most important factor. Here the T1 which sends, or the satellite which sends the signal, and that signal will be received by the rover or the receiver at the time T2, that is receive, send and receive. So time in between that sending and receiving is called as the elapsed time, which is the basic working principle where distance is equal to velocity into time. Most important point, the concept of trilateration. Trilateration is the mathematical process used to determine the exact position of receiver, where satellite, n number of satellites or many more satellites, three types of satellite plays role togetherly. One satellite provides a spherical range of possible locations, just like image 1, position is somewhere on the surface of sphere R1. Two satellites narrow the location to the intersection circle of two spheres, just like image 2, R1 and R2. Two satellites where position is somewhere on the intersecting circle. And the three satellites determine the exact three-dimensional coordinates of the receiver, just like image 3, where R1, R2, R3 is there. So impossible point to mark, so that the earth point will be on the basis of latitude, longitude and elevations, where intersection narrows to the single local point, that is based on the Cartesian coordinate system x, y, z. So in civil engineering point of view, this trilateration, which is the use for precise positioning in GIS mapping, road alignment and deformation monitoring. Most important topic, that is global GNSS constellations overview, where big four global constellations are there. First one GPS, second one GLONASS, third Galileo and fourth one BeiDou. The major global GNSS constellations are these four, where each constellation is developed and operated by different countries or organizations, just are explained in the map. Likewise, multi-constellation systems improve signal availability, positioning accuracy and reliability. Here, the regional systems such as India's NavIC, or we can say that IRNSS, which is a regional one. Also, Japan have this Quads, which is also a regional one, which provides specialized coverage for specific regions only. In civil engineering domain, for any construction project or for the planning or surveying point of view, GNSS systems improve survey accuracy in urban and mountainous regions or any type of environment. First one will be the GPS, which is operated or owned by the United States, which is also known as the NAVSTAR, where owner is the United States Department of Defense. The constellation specifications are follows. Satellites, nominally 24 satellites are there, currently are 30 plus operational. Orbit is of medium earth orbit, altitude is given, then period, that is 11 hours 58 minutes, repeats ground track, that is one cycle timing, which is a period, and planes are 6 orbital planes inclined at 55 degree, like geosynchronous. So GPS also called as NavStar, where satellite orbits are approximately 20,200 kilometers above the earth. GPS satellites are arranged in 6 orbital planes inclined at 55 degrees. In civil engineering point of view, that GPS is widely used for surveying purpose, machine guidance purpose and GIS based infrastructural planning purpose. Next one will be the GLONASS, which is owned by the Russia, which is fully operational of 24 satellites, where orbit is 19,100 kilometer, which is in the lower than GPS position. The technology distinction point of view, historically used by FDMA, that is frequency division multiple access, but distinct from GPS CDMA. That is, GLONASS is in the Russian GNSS system, while Galileo is developed by the European Union. Both the systems are fully operational with 24 satellites in GLONASS and 30 satellites in Galileo, interoperable or interconnected with GPS for improved global coverage. With reference to GIS and civil engineering domain, combining multiple systems which improves positioning in different terrains and urban areas, so that these systems are most powerful and effective for the same. Next one will be the BeiDou and IRNSS, that is NavIC. BeiDou, which is based on or owned by the China. BeiDou is China's GNSS system and has evolved into a fully global navigational network, where three-phase development strategy of fully global 35 satellites are there. These 35 satellites are of mixing, that is MEO and GEO, geosynchronous or other geostationary satellites. Then India developed NavIC, or we can say that IRNSS, to provide interdependent regional navigational systems or services. NavIC covers India and surrounding regions within approximately 1,500 kilometers. NavIC uses geostationary and geosynchronous satellites for regional coverage. With reference to civil engineering point of view, regional systems improve local positioning, reliability and disaster management applications. These NavIC have the constellation of 7 satellites, that is 3 are geostationary and 4 are the geosynchronous. 3 geostationary satellites are fixed over equator, while 4 geosynchronous satellites are figure 8 loop over region. Strategic point of view, that all satellites are independent positioning capability for Indian civil and defense applications. What are the technical comparison of GNSS system? The 4 systems: GPS, GLONASS, Galileo, BeiDou, owned by different countries. We can compare these on the basis of some features like satellites, then altitude, period, and coding. So different GNSS system vary in satellite numbers, orbital, altitude, and operational coverage. GPS and Galileo mainly use medium Earth orbits satellites for global positioning. NavIC uses geostationary and geosynchronous orbits to maintain continuous regional visibility. Combining these all GNSS systems improves satellite geometry and positioning precision. So in world, with reference to civil engineering point of view, GIS and remote sensing used in the various construction projects, multi-system integration which increases reliability and reduces surveyor errors. So what are the sources of errors in GNSS? Basically, GNSS accuracy is affected by ionospheric and atmospheric signal delays. Ionospheric delays, that is charged particles, and tropospheric delays, that are due to the weather or any type of pressure, that is wind pressure or any other gaseous pressure. Then multipath error occurs when signal reflects from buildings, terrains, or any structures before reaching to the receiver. Poor satellite geometry causes dilution of precision, that is DOP, reducing the positioning accuracy also. So ephemeris errors occur when satellite orbital information is slightly inaccurate. So ephemeris error with orbit deviation point of view, the path of the signal which is mentioned in the diagram. In the civil engineering point of view, for any project, we are dealing with the minimum error. So minimizing these errors is essential for precise surveying and mapping purposes. Now, most important point based on the DGPS and SBPS, that is augmentation. Differential global positioning system, that is DGPS, improves accuracy using a fixed base station and rover receiver. As mentioned, that DGPS transmits correction data to reduce positioning errors significantly. That SBPS, which is a satellite based augmentation system which provide wide area correction services. That India's point of view, in India, GAGAN system enhances GPS accuracy for navigation and surveying applications. So in civil engineering domain, that augmentation system supports centimeter level precision for infrastructure projects, so that the surveying is more precise based on some satellites or n number of satellites at the same time. So relevance to the civil engineering domain with reference to the application point of view, GNSS is widely used for establishing control points and boundary surveys. Machine guidance systems use GNSS for automated grading and excavation. Real-time monitoring, which helps or which detect the deformation or displacements in bridges, dams, and other critical infrastructural projects. GIS integration allows engineers to analyze spatial information for planning and management point of view. GNSS has become an essential technology nowadays for modern civil engineering measurement and monitoring perspective. So concluding part is that GNSS is no longer just for navigation purpose. It is the primary tool for spatial measurement in modern civil engineering era, based on some surveying, mapping, machine control, and structural monitoring with reference to the real-time data collection. Stay tuned guys. Happy learning.